So I'm going to define a new term called a one-to-one function. So first we have to determine whether or not something is a function to begin with, because if it's not even a function to begin with, then it obviously can't be a one-to-one function. So if I look at these sets I have here, can you see that this first one is not a function? Because if I put in a 3 and sometimes I get out a 5, and I put a 3 and sometimes I get out a 6, that would make it not even a function to begin with. It would fail that vertical line test. If I were to plot those points on a set of axes, 3, 5 might be here and 3, 6 might be here, and you could see that they would fail that vertical line test. They're right on top of each other, right? So the x's cannot repeat to determine whether or not something is a function. So this one, this one is not even a function to begin with, okay? But the second and third one, they are functions. It is okay for my x values to give me a 7, I can put in a 3 and get a 7, and I can put in a 5 and get out a 7. That is fine. My y values are permitted to repeat. It's the x values that cannot repeat. These, if you were to plot these 2 points, 3, 7 and 5, 7, hopefully you can see or picture those in your mind. Those would be horizontal to each other, okay? So they would pass the vertical line test. So this is a function, this is a function, and this is a function as well. But this one down here is what we're going to call one-to-one. Notice that as I put in, every single x value is unique. I have a 6, a 7, a 9, and a 3. So those are all unique x values. And then I have unique y values, 8, 1, 0, and 5. Okay? They just need to be unique to each other. Because I could add another point here, 8, 6, okay? And that's fine. Because remember, just read them off as x's and y's separately. So I have here 6, 7, 9, 3, and 8, and none of them repeated. And then for the y's, I have 8, 1, 0, 5, and 6, and none of them repeated. So as long as nothing repeats, then we call this function this is going to be a one-to-one function. And I abbreviate it as just one-to-one. Okay? Now, there's going to be a new test that we can test for this, and this is going to be the horizontal line test. So hopefully you can see that if I plot all of those points, not only is it going to pass that vertical line test, but it will also pass a horizontal line test. So you should be able to tell whether or not a function is one-to-one if we just give you a list, kind of like any of these, or if we draw a graph. So let's look at some of our graphs really quick and determine whether or not something is one-to-one. So if I draw a graph that looks like this, that is a function, but it is clearly not a one-to-one function. So it's okay that it's a function, but it's not one-to-one because it does not pass that horizontal line test. So what if I look at the parabola, the x squared function? That is not a one-to-one function. It does not pass that horizontal line test. But the function, let's say the square root of x, that looks like this, right? And that is a function, and it also passes that horizontal line test. So this one would be one-to-one, okay? But these two would not be one-to-one, okay? So just, look, you can draw the graph. You should know what all your 5 functions look like that we're doing in this chapter. And what I suggest you do is if you're given an equation, just draw a quick little sketch for yourself and see whether or not it passes that vertical line test. For example, another example, what about the absolute value graph? Does that pass the horizontal line test? Well, no, so it is not one-to-one.